eddy currents. If you have a metallic sheet like this, a metal, but suppose this is a metallic sheet, any enclosure, for example, transformer, stabilizer, air conditioner stabilizer, surrounding structure is what? Iron, steel. So there is a sheet of iron. So in case you have a sheet of iron, place a magnet nearby. If you place it at rest, nothing happens. And now you start oscillating the magnet. If you start oscillating the magnet, after some time, what you observe is the temperature of the sheet increases. What is the cause? If we come out with the cause, why it is so, then this sheet you can think of made up of wires, am I right? Loop. Like if you take a tape roll, start from here, keep on moving, the dia of the disc keeps on increasing. So it becomes a disc. Similarly here also, if you keep on placing loop over loop, then this is what? It is a sheet. From North Pole, flux linkages, magnetic flux, phi is available. When you move it in and out, the flux linking the loop changes. When the flux linking the loop changes, there is a rate of change of flux. Whenever there is a rate of a change of flux, an EMF is induced, such that it tries to oppose the cause. So when you move it in and out, what I am doing is mechanical work. It will appear in form of a heat. So heat generated inside this metallic part is due to some flow of current. That current is known as eddy current. So what is eddy current? We summarize. Eddy currents are the currents induced in the body of a conductor when the amount of magnetic flux linked with the conductor changes. They are also called as Foucault currents. Time with you is 2 minutes to explain what we mean by the term eddy current. 2 minutes to write. Now we have examples or applications. When you say example and application, there is a difference. Application is that you use it intentionally and the use is good for you. Example can be something not desired. So one example is, you take a transformer, you place it in an enclosure, metal enclosure. So what you expect or what you want is only this part to work, but you have a metal enclosure surrounding this. When the magnetic flux is changing inside the core, there is a magnetic flux variation with the metal part also, and this enclosure also gets heated up. This is not desired. So This is what? An example. It's not an application. This heating. So now we'll have some cases and you will come out whether it's an application or an example. Competition objective choices. You need to be very take care of this, sorry. You need to be very careful that whether it's an example or an application. Choices are very close. So enclosure of a transformer gets heated due to eddy currents. Is an example or application? Example. Because it is not something desired. Now we will have something which you want. 1. Electromagnetic damping. Let us first analyze what the problem is. Existing. I mean, in case you don't apply this, then what the problem is? Problem is, you have a device 0, +1, +2, -1, -2 galvanometer, and at present the reading is say +1. Now you want to use the same device in some other circuit. You will first what do? Switch off. Agreed? When you switch off, it should come to 0, but won't. It will overshoot. That means this will keep on oscillating and you will wait till it becomes 0. And it is one of the cases where you observe 0 setting in daily life is a petrol pump. Agreed? The person will generally come out with a call. Bauji 0 dekh lo. Agreed or not? The person comes out to the call. See, 0. You wait that the instrument is 0. All readings are 0. Then you start filling petrol, diesel, whatever it is. We call it 0 setting time. So you cannot use it till it comes to 0. So there is a problem. So first part is that to understand there is a problem. If there is a problem, then we have a solution. What is the solution for the same? Solution is there is a magnetic field. How galvanometer works? There is a magnetic field inside and there is a coil. So there is a coil placed, current flows through that coil, and because of that this needle moves. Agreed or not? So when current will reduce to 0, it will come to the 0 value. Now the arrangement is that you attach a metallic strip, metal part at the end of the needle. Now how this will solve the problem? Anyone? How this can solve the problem? It is at any value. When you reduce, when you switch off, when the current in the coil becomes 0, then it will have tendency to come back to original position, 0 position. You can mark this as a reference or this as a reference, makes no difference. This metal is present in a magnetic field. When this metal oscillates, EMF is induced such that it tries to oppose the cause. What was the cause? A relative motion. So it will oppose the motion. The result is, if it takes 1 second time to settle to 0, this may take 0.1 second time to settle to 0. That means in the earlier case, if the damping was of this order and the time taken was say 1 second, in the second case the damping will be very fast and it may take say 0.1 second. What is the advantage? You saved what time? How much time you have saved? 0.9 seconds. So you have reduced zero setting time. Electromagnetic damping. Time with you is 3 minutes. You have 2-3 objective questions which deal with the same. 3 minutes to pen down. Electromagnetic damping. First define the problem, that there is a problem, then come out with a solution. Induction furnace. Induction furnace is a big room size furnace, a big enclosure. Surrounding this enclosure is a wire. You place scrap, used iron material, scrap, inside the same, say any piece, any object. You dump it, cover it, and then you allow the current to flow through the same, alternating current. If alternating current, that means current first increases and becomes maximum, zero, negative. If this current changes, magnetic flux linking the scrap will also change. If the magnetic flux linking the scrap changes, EMF is induced. This EMF induced is such that it tries to oppose the cause. So it causes what? Heating of this. Heating is to such an extent that the whole material melts. And this is after a few hours, it is a liquid container. Iron melts because the temperature achieved is more than its melting point. And then you draw it in form of a rod to be used in construction material. This is how scrap is changed to iron rods for construction. What is the function of the induction furnace? Apply alternating current. Alternating current will do what? First part is apply AC. It will do what? Change flux. Changing flux will do what? Induce EMF. This induced EMF will do what? High current. This current causes what? Heating. Heating will do what? Melting. And you can draw this in form of rods. This is how induction furnace works. Competition question. Yes. Can a DC do this? Objective question. Can a DC voltage do this? No. Because if you apply DC, current is constant, flux is constant, there is no rate of change of flux, there is no EMF. 1. 2. If you increase the frequency from 50 Hertz to 100 Hertz, Will it increase heating or decrease heating? If you increase the frequency, that means fast rate of change of flux will be high. If rate of change of flux is more, heating will be more, time of heating will get reduced. That is why you use high frequency AC. Objective question. Objective in induction furnace, what you use is A choice DC, B choice normal domestic application AC bracket 50 Hertz, C choice high frequency AC. Correct answer is high frequency AC. Reason for everything. You have reason for everything. Third application is what? Electromagnetic brakes. So there is an electric train. You have mechanical brakes. For example, in a cycle, you have a mechanical brake. The rubber part will touch the wheel, inner part, that is rim, and because of friction, the wheel comes to rest. So kinetic energy of the vehicle changes to friction heat energy due to friction. This is one. Now in this arrangement, this is the axle, and say this is the wheel. So this is from this angle. This is the axle, one wheel on this side, another wheel on this side. We see the photograph from this end. Getting what I'm saying? So this is wheel 1, this is wheel 2. If you see the side view, then it will, if I see it from this end, then it appears to be a disc. Agreed? This is what a wheel is. If I see it from this end, then it is a disc. If I see it from your end, then it is not a disc. Then it is this shape, 1. So wheel is in motion, train is moving at 100 km per hour. Now you want to stop it. Option number 1, you can apply mechanical brakes, you have it. Option number 2, ferromagnetic material. On the ferromagnetic material, you have a winding wire. So this switch is off. Now you want to apply brakes. If you want to apply brakes, switch on. The moment you switch on, there is a current flowing. Because of this current, there is a flux. That flux, magnetic flux phi, will link the wheel. And wheel is in motion. So an EMF is induced because of relative motion. EMF induced such that it tries to oppose the cause. What is the cause? A relative motion. So it is non-contact type. It has theoretical infinite life. Non-contact, it is not touching. That is why this braking is very smooth, very effective, less maintenance and long life. Theoretically infinity. CD, all of you seen is, how many of you seen a cassette with the roll or reel? How many of you have seen cassette? That's good. In a cassette, roll or reel will touch something. Agreed? But what about in a CD? It is some signal, agreed? It can be a laser, it can be some sort of light, non-contact type. So theoretical life of a CD is infinity. But still, CD is, you can say, lose quality after some time because there is some dust, there is some other reason, but theoretically the life is infinity. Here also it is not touching. So back. How it works? Wheel is in motion. You will switch on the current. Because of this current there will be flux. Because of flux there will be rate of a change of flux. EMF is induced in the wheel, that is eddy current. And it will be such that it will try to oppose the cause. What is the cause? Relative motion. Disadvantage, anyone? There is a sphere disadvantage of this. Anyone can think. Let's see how many think. There is a disadvantage of the same. Yes. Yes? Heats up very much, that's one. And he says heating is too much. See, that's not acceptable. Reason is, see, there is a kinetic energy of the train. Train is moving at 100 km per hour. So there is a kinetic energy. Initial kinetic energy, final is 0. If you use mechanical brake, even then the change is the same. Use electromagnetic change is same. So this argument is not acceptable. Not an issue. You have tried. We have equal respect for a wrong and right answer. You are trying. Yes. Current. This value is low voltage DC, 50 volt. So, yes. Yeah. We. Yes. Then what? Yes. That will. No. Even this wheel won't melt. Small heating only. The purpose is not high heating. Anyone? Jerk. This is quality braking. This is recommended. High speed trains. Smooth, very smooth braking. Excellent. The disadvantage is it cannot be applied to a train at rest. You have a question. If the train is at rest, what is the need for braking? Am I right? How many of you will answer this? That it is required. You are moving from Chandigarh to Shimla, slope. So you have a stoppage at Solan. 5 minutes. Now, it doesn't work. It doesn't work. That means you will have to support it with the backup, another braking system, another mechanical system, which you will have to use when the train is at rest. You will have to use those brakes. This is not one of the questions in competition. The disadvantage of electromagnetic braking is choices. One of the choices is not applicable for vehicles at rest, because it comes into play only when there is a relative motion. Time with you is 4 minutes to write. 4 minutes to write. Fourth application is what? Induction motor. In induction motor, suppose you have a cage. And surrounding the cage, you can make an arrangement such that there is a magnetic field moving around it. For the purpose of explanation, I can do it like this. So there is a cage in this form, and we can produce a rotating magnetic field. There is a coil 1, coil 2. So there is a current in coil 1, it will be reduced to 0. Now the current is in coil 2. That means here it is north pole. After some time the north pole is at this position. After some time it is this position. That means what? You keep on changing the current from coil 1, 2, 3, and it behaves as if there is a rotating magnetic field. Fan is an example of this motor. So when you move it in, say, circular motion, then the flux linking with the cage will change or not? Whenever there is a rate of a change of flux, there is an EMF induced. So there is an EMF induced. So suppose there is a current flowing. The current flowing will be such that it will try to oppose the cause. How it can reduce the relative motion? Suppose there is a train moving, and if you start running with the same speed, relative motion will get reduced to 0. So when this magnet moves from this position to this position, this ring tries to reduce relative motion. So it has shifted through certain angle, it will also shift. It has shifted through certain angle, it will also shift. So the magnet rotates and this cage tries to follow it. So this is a rotating field. It will do what? It will cause rotation of the cage also. This is how induction motor works. For domestic application, fan. At the center there is a magnetic field, rotating magnetic field, and the enclosure, the outside, this metal part tries to follow it. So in that process, rotation takes place. Blades are at certain angle. They will push the air downward. They will set the air in motion and will cause cooling effect. That is how the fan works. Fan motor also works on this principle, and it is termed as, its engineering nomenclature, fan is single phase induction motor. So this is how a fan works. Procedure is, what you set as rotating magnetic field. EMF is induced. It will try to do what? Reduce relative motion. How? It will also, the cage also starts rotating with the field. And if now I draw it, if you attach a fan to the same, fan is also set in motion, rotational motion. Time with you is 3 minutes to write. 3 minutes to write how an induction motor works. Fifth application. Speedometer, domestic application, energy meter. Conventional energy meter, not electronic energy meters, conventional energy meters. What was the conventional energy meter? Whenever you have current flowing through, so there is a disk rotating. You can say 30 years back, 20 years back, these meters were in operation. Now you have is electronic energy meter. So there is a disk rotating. Same way, if the value of current is more, disk rotation is also more. Power consumed, P, is equal to V into I. Voltage remains a constant. Power is proportional to what? Current. If you draw more current, you get more rotations. So your energy bill will be high. So same working principle, no change. Speedometer also. If the wheel speed is more, EMF induced will be more, rotation will be more, so indication will be more. Speed is proportional to the same. Sixth and the last application is eddy currents are also used in diathermy, in deep heat treatment of human. Heating. Let us first try to understand heating, what heating is. One is sometimes surface heating. Gulab jamun, if you heat it by flame, using a flame, that means you are touching the surface only. What in a microwave? Yes, in a microwave, try kita. In a microwave, when you heat it, when you break it, it is very hot at the center because it is volume heating. Heating takes place at all levels inside, throughout the volume of the sphere. So heating can be surface heating or volume heating. Now suppose there is injury to this finger and some heat is required. So what we do is we place a coil on the same. Will flow alternating current. This is also conductor, your body is also conductor. So eddy current will be produced. Some heat is produced inside. That heat produced will relieve me of some pain, may improve the blood circulation. So it is volume heating. That is how it is used for heating purpose also. That is point number 6. Eddy currents are also used in diathermy and deep heat treatment of a human. Time with you is 3 minutes to write.